Hello to everyone, and I finally managed to move my engine to CMake. It's my game engine, this is it. It's a lot of classes and header files, and I'm using it to create a Minecraft clone. I can quickly play the Minecraft clone by using this. This is the Minecraft clone. It's like I explode a bunch of TNTs. That's the Minecraft clone. I can even show it now. That was probably either 10,000 or 100,000 TNT. And all of this now is running in CMake in Linux, particularly in Arch Linux. And I managed to move it in Arch Linux by using CMake. Before, this was the project before. It was using premake. This is how premake looks like. It's easier to use, and it automatically creates your Visual Studio projects. The issue is that other libraries that you use, most of them are for game development are open source, and they use CMake. So when you integrate them, where is the folder? Here are all the libraries that I use: GLAD, glfw, glm, imgui. And if we go to glfw, it has a CMake like configuration, ready to use automatically. You don't have to do much except set some flags and definitions. But when using premake, I had to generate the whole premake myself, and that's for every project. Like if you want to use the source code and like build it with the engine as well, which makes it easier to send the code to somebody else to run it, because they don't have to download each library as well. Yeah, here for GLAD. GLAD didn't have CMake, so doing a premake or CMake like is the same amount of work. And why did I move it? Like premake has this cool feature where you can build it for Visual Studio Code and you can build it for Linux as well. And it creates this make file. I did that and I had problems running it, and I had no idea how to change it to make it run. And I didn't want to bother like having to understand the computer generated make file. So I decided just to learn CMake. It will make everything a lot easier. And the other thing is that I really want to switch from Visual Studio Code to NeoVim. This is a NeoVim environment. And the issue I had is, for example, if I start working on the project with NeoVim, I tried that, and here I get like all of these random errors. Like there are no errors in the code. Like the game runs, the engine runs, but I still get them in like NeoVim. And to not get those errors, you need a file. JSON file. This compile commands JSON. This removes all the errors. And in Visual Studio, I had to go in Visual Studio Code and generate it with some kind of extension. And even generating it with the extension, I still had all of these errors. Like not all of them, some of the errors disappeared. Like it was quite a mess trying to move to NeoVim. And so now that I am using CMake, in CMake, the super cool thing is here I have presets in CMake, and I can just set this preset on. CMake export compile commands, which automatically will generate this compile commands JSON file in the build directory. And so now if I go in the engine and I go in applications, here there are absolutely no errors. Like if I get a warning or an error, it's supposed to be there, and I can actually look at it and try to fix it, knowing that it actually exists and it's not some made up error. So for this video, I moved my game engine to CMake. So why I moved the engine, I explained it. Premake code versus CMake code. Yeah, the cool thing about CMake is it has many cool features. Like one of them is this CMake presets. This is one of the presets, and a preset inside of it you can configure a lot of stuff for the project, and you can create another preset with different configurations. So when you build the whole project, you can write here at the bottom CMake preset, and I've called it the default one, but it can be a different preset. But in premake, for example, like maybe there's something like that, but me personally, I've just tried both and I just preferred the CMake route. And the cool thing about premake, I'll give it to premake, is that it's a lot easier to get into premake. Like it's like a lot of the stuff are self-explanatory. If you look at some other project, it will look quite similar to this project. The issue with CMake is that, like, here is one of my CMakes. This is just for the entire thing, but we have in subfolders other CMake files. The issue with CMake is that I've decided to do it in one way, but if we go into GLFW, for example, they have their CMake and it looks a lot different than like mine CMake, and they may use something that I have never used before with CMake that I have to look up and learn. Whereas with premake, most likely there'll be little differences between configurations. But the coolest thing about CMake is that like I can reuse, like for example, GLFW's CMake. And if I have to make one myself, like for example for GLAD, here I had to make a CMake myself, and look at how simple it is. It's just to create the static library, a library target, and to give it source files, like to give the GLAD C file, which is in source C, and to include directories, which is this directory, the include directory, and that was it. And inside my project, I just had to add subdirectory GLAD and to target link libraries, to link the voxel engine static library with the GLAD library. And GLAD is just so I can use OpenGL, because OpenGL is a specification. The implementation is written in the graphics drivers, and for the game to know where to find the actual implementation, that's the job of GLAD. It actually makes it easy to actually use the OpenGL implementation. Showing off the engine, we saw the engine run, but we can, like the Minecraft clone. We saw the Minecraft clone, but we can change it. We can change it. Right now it's 100,000 TNT. We can make it 10 million TNT. We can make it 10 million, and we can just build the project to compile the change, and we can run it like this. And this is the entire project, and we can just activate it. This is 10 million TNT. And the FPS at 10 million TNT, of course, lowers, but not as much as the original. And all of this runs in Linux, Arch Linux specifically. I moved from Debian to Arch Linux because I'm years ago, the first Linux system I tried was Arch Linux. I used it for a year, so I got accustomed to Arch Linux. Moving to another Linux distribution just takes time to get used to it, so I just got back to Arch Linux. And this is my fourth Minecraft clone, and with these live streams, I'll just make short streams like this one, where I'm show from time to time where I'm at. And in the main channel, you can see the actual full video covering the entire development process. And I have 4 videos for each of my 4 Minecraft clones, and that's in my PESA CS main channel. This is just for the live streams channel. And this is the extent of the project. I can hit F3 and if I hit F3, there should be like, I'm trying to hit F3, but in NeoVim, I've set it to something else and they're causing an issue, so I can change it some other time. In the project, in the Minecraft clone, you can destroy blocks, and we have support for texture packs. This is I forgot the name of this texture pack, Bare Bones, I think it was called, but I can use many other texture packs. But I have to specifically make it work for each of those texture packs. I have to make changes in the code because some texture packs work differently than others. But I've used like 5 or 10 different texture packs, which is just in this assets folder, textures, and here inside the texture pack, I move the assets folder inside from the texture pack that I download. And it just has all of these, how do I resize this? It has all of these different separate PNGs. And the cool thing is that the project combines them in a single texture pack. That's the cool thing that I managed to do in my fourth Minecraft clone. But this video is not about that. It's switching to CMake. The code will not go everything, just like so we have a vague understanding. I have Minecraft clone, the project, and the voxel engine itself. And the cool thing is that I followed the Chernow's game engine series. That's the way he did it, and I replicated it following his tutorials. And the cool thing is that this is my fourth Minecraft clone. And in my past Minecraft clones, the engine code and the Minecraft clone were one whole project. They were not separated. So this folder and this folder were one whole thing. And every time I started over, I had to start completely over. But now, for my fifth Minecraft clone, I can just delete this folder, the Minecraft clone, and not have to start over the engine itself. And this was the goal with moving to CMake, is to be able to reuse this code here, the engine. The engine uses these precompiled headers, which is precompiled. It includes that have to be frequently used, like arrays, vectors, strings, and if you constantly just include them everywhere, it will slow up your like compilation of the whole project. But if it's in a precompiled header, it like makes the compilation process faster. That's something new I learned from the journal. And my Minecraft clone, I think, just includes this voxel engine header file, which has all the different includes from the engine itself. so it's much cleaner and organized. And it also includes this entry point. The cool thing is that the main function is written inside the engine. So when you're making a project that uses the engine, like here, the game layer, you just include the entry point. You just include the entry point, and oh yeah, it's in Minecraft. It's in this file. You just import the entry point, and you have your main function. It literally copy pastes this code. You don't have to have it yourself. And no type named application. Yeah, I'll look this up afterwards. And when you create an application that uses the voxel engine, you just have to create your a class that inherits the voxel engine application class, and inside it, you here I just push one layer that is the game layer, but you can have many other layers, and this layer system is really helpful. I didn't have it before. With a layer system, you can have a layer for the menu and a layer for the game. So when the player moves from the menu to the game, it's an easy switch between the two. In my previous Minecraft clones, it was a complete mess, and the switch between the two was like very annoying. And what the application has to do is just define this create application function, which just creates a new instance of this class that we created here. This is the only thing that the engine needs. It knows it inherits the application. So inside the engine, it can use this function to create the application, and then it activates this run function, which is defined here. Here, the run function with implementation here. And here, this while running, it's a separate boolean. The kernel did it this way. Instead of just checking the glfw check so that you can close the window, but everything can still be running. And the cool thing about this engine from the kernel's tutorial, it's not my implementation, is the event systems. The event system is super cool because it makes handling key presses really easy. Inside of the game layer, we have the application, the class we created that inherits the game, the voxel engine application class. It has this function on event. Whenever there is an event, the layer gets it, and we just check it if, for example, is a mouse button released event. And if it's a mouse button released event, we just make a callback function that gets called if it's that event. And here I've set it like the mouse button left, it's for activating TNTs or destroying blocks. Here I have for key pressed, and here I check if it's the escape key, we close the application. If it's key 1, I change the camera speed to be slower. If it's the number 2 key, I make it like the speed to be half as slow, and here the fastest speed for the camera. And we have for when the mouse has moved, this is so that we can change the camera. And for the window resize event, we recalculate the projection matrix, so that when the window size changes in OpenGL, everything doesn't look weird. And I don't know what else could be interesting to be shown. Right now, like my streams don't get much attention, so that's why I'm not looking at chat. But when more people gather up, that's when I'll start looking at chat. So right now, I have to think of what would be interesting for you guys to see. That's why I want your feedback, your comments, for you guys to tell me what you want to see. I want to make these streams something you would want to see. Yeah, okay, so the focus is of CMake. Like, why did I make the move? Like I've explained it before, but I can add on that as well, because that's the focus of the video. Yeah, I mentioned the point. Yeah. I could have just stayed with Windows using premake. If I stayed with premake, because I had to invest a lot of time to move to CMake, I had to learn the basics of CMake, which I streamed in this channel. I had to invest time in learning CMake. I had to invest time into installing Arch Linux, into moving my whole environment into Arch Linux. Like, it was a big time investment. So why didn't I just stay with premake with Visual Studio Code in Windows? I could have done that, but I'm trying to think of other reasons than the ones I mentioned. And yeah, I cannot think of other reasons than the ones I mentioned. Maybe another reason is that I haven't seen anybody else use premake. Like, I saw premake from the Chernoz's game engine series. He used premake, that's why I use premake as well. That's the first time I learned about premake. But CMake, I see it everywhere. Either they don't use anything or they use CMake. That's it. So that's my biggest motivation for like moving with CMake, because everyone else uses it. And yeah, that's the stream. I'll stop it here. It's enough. Let me know, guys, what you want to see. This is, if you comment anything, comment this. What do you want to see from here? What I'm going to show from here on, if there's no feedback, I'm going to show, like, I'm working on my fifth Minecraft clone. I'm working on my fifth Minecraft clone. It will be with C++ using this engine, and I'll add the nether and villagers, redstone. That's my goal. And before, I would just do the whole project and make a big video in my main channel. But this time, the difference is that in this channel, from time to time, I do live streams just to show my progress. That's the goal of my current live streams, to show the progress. And this is my current progress. I moved the engine to CMake. This is my current progress. And the next stream will be my next progress. For example, like starting the fifth Minecraft clone. Like, I have the terrain generation in my fifth Minecraft clone. For example, that would be the next stream. And the next stream after that would be, I have like infinite world generation, for example, using threads. That will be, for example, the next stream. And like that for 2 months until the main video. So thank you guys for watching, and I'll see you in the next stream.